All right, gonna push the limits of my little iPad and see if this works. Conservation of energy, you may have heard, this is one of those old ones. First law of thermodynamics. If we were in class, I'd get you guys to see if you could figure out how this one goes. Like Newton's laws, some of you knew off by heart. The start of conservation of energy says energy cannot be, the rest of it is created or destroyed. And then there's that second part, energy can be transformed. From one form to another. Okay, that's it in words. It's old, it's kind of cool. We're going to do it in math, but before we get to it, it may crash. We're just going to stick with the two kinds we've been talking about, gravitational and kinetic. I'm hoping my iPad can handle this, but I've got this visual. I'm going to flip screens and hopefully my iPad doesn't crash. I'll kind of give you a visual of the energy sloshing back and forth. So switching screens into Safari. You can see the address up top, PHET Colorado EDU. That's a school in the States that does physics coding. Their students have to do physics coding assignments. I'm going to take my little skateboarder and drop her onto the track. Oops, there she goes. And then I'm going to blow up this graph. I like this one because it kind of shows the energy sloshing back and forth. When she's way up high, over on the left, the blue one is potential. They just were lazy gravitational potential energy. Whenever she's up high, she's got a lot of gravitational potential energy. And then when she's down low, all her joules go into kinetic. So the energy's going kind of back and forth between potential and kinetic. I'll see how good I am at timing. If I pause it when she's at the very top, pause it. Notice how very, very little kinetic energy. If I paused it perfectly, there would be zero kinetic energy when she stops at the top for a split second, but all her joules are potential. If I let it roll again, pause it at the bottom if I can. Well, not bad, but all the joules are kinetic because she's moving her fastest and she's at the lowest. This is what a nice visual of the energy sloshing back and forth from kinetic to potential over and over again. Sometimes I put it in analogy of a bank account. Imagine you got a bunch of money and two bank accounts and you kind of slide your money, transfer your money from one bank account to another. In theory, you shouldn't be losing any money. It just sort of slides back and forth from one form to another. I'm going to pause this video so it doesn't crash and then we'll do some number crunching on conservation of energy.